Alrighty, today we will be discussing arithmetic sequences. And it's not too bad because it's an extension for what we did last week, where we just talked about what sequences and series are. The pattern that creates a list of values and then adding all those values together. And today we're talking about arithmetic sequences. This is a specific sequence that adds the same number each time. So it's not too bad. Some of the sequences we looked at last week, there was a pattern within the pattern. This time we will only have that one single adding the same number every time. Of course, it could be adding a negative value, which often looks like subtraction, but that won't trip us up too much. The value that gets added or subtracted the same every time is called our common difference, and we're going to label that D. And you can easily find that by subtracting a sub 2, which is our second term, minus a sub 1, which is our first term. And you don't have to check it every single time. If it tells you it's an arithmetic sequence, we know that that D does exist, so we really only have to find it that one time. All right, we've got this nice formula, a sub n. Don't forget that a sub n is any given term. Let me make some notes here. There's a sub n, that's any given term in the sequence. So we're creating that explicit formula that allows us to find any value. We have to have the first term, and then it adds on a specific value, and that's this D value. So notice it's adding this D right here. The reason why it gets a little bit weird with this n minus 1 is because, like our functions, our linear functions, the first term is actually n sub 0, yet in our sequence, it's the first term is 1, n equals 1. So therefore, we have to subtract this 1 to get back to the 0. It doesn't really play that big of a role because if I can find all these pieces, then I can create this equation and then simplify it as necessary. So we're not going to worry too much about that 0th term that you'll hear me talk about. What's really important about this is this n. This n right here is directly related to a sub n. They are not the same number. A sub n is the value of the nth term. N is the actual number of terms in the sequence. So take a look at example 1. When it says find the 38th term, 38 would equal n in a minute, but 38 is not the value of a sub n. And I'll talk more about that here in a second. So once again, this formula is for any given term, a sub n, and we need the first term, a sub 1. We need the term number for whatever a sub n is, and then we need D, the common difference. And really, since a sub n and the n value are tied together, we really only have 3 unknowns here. The first term, the term I'm looking for and its value, those are tied, and then the common difference. If I've got two of those 3 pieces, then I can easily use this equation to find the other missing piece. And then I will have my complete formula and can use it to find any term in the sequence. For example, if I wanted to find the 38th term of this sequence here, of course, we could understand that it's just adding the same number every time. So why don't I just save myself the trouble and add whatever value it is every single time? Because we'd have to go 38 times, and that's a lot. However, the first thing we need to do is find D. So the difference between -7 and 5 is +2. So that's our D value. Our D value is +2, okay? Now again, we could add that because this is n equals 1, first term, second term, third term, and then we could just go all the way to the 38th term, but that would take a long time. So let's use our formula. So we know D is equal to 2, and then we know a sub 1 is equal to -7, yeah? Nice. So if I want to find the 38th term, that, my friends, is n. N is the 38th term. A sub n is not 38. N equals 38. So when I write a sub 38, that means the 38th term, n equals 38. And then I can simply plug in my values that I know, start with -7, and I'm going to add the same value every time. But I'm going to start with, or sorry, I'm going to jump to the 37th term times d value, which is 2. So all I did was plug in a sub 1 here, and then n, which is 38. That's the term I'm looking for. And then 2 is my common difference, d. So like I said, jumping to the 37th term, that's because we have to assume that the first term is n sub 0. Doesn't really matter all that much. Okay, now we're going to just evaluate this. If you have a fancy calculator, you can plug it straight in your calculator. 38 minus 1 is 37. 37 times 2 is 74, plus -7 is 67. So therefore, a sub 38, the 38th term in this sequence, is equal to 67. Easy peasy. So again, we just used our formula for the arithmetic sequence. And when I asked for the 38th term, that told us n. And then when I saw my sequence, the first term, -7, that's a sub 1. And then the difference, what it takes to get to the second term, is d. All right. Let's try another one. Ruh-roh. So this time, we don't know the sequence. We only know a sub 1 and a sub 5. Some people think they can create some pattern and add some specific value to get there. You could, but because we have the formula, it makes that a lot easier. So d is going to be our variable in this one. That's what we're looking for. And then we know a sub 1 and we know a sub 5. Here's the good news. When I know a sub 5 is 4.4, that means n equals 5, because that's telling me the fifth term is 4.4. So that means I could use my formula for a sub 5 like this. A sub 5 is equal to a sub 1 plus 5 minus 1 times d. So you see how it gives us a sub 5 here, and then that 5 is what plugs in for n. That's how those two things are connected. But we're looking for d, but they tell us a sub 5 is 4.4. So that term is 4.4, a sub 5. A sub 1, they told us is 3.2. And now we have the rest of our formula and can solve this for d. So simple math, we're going to subtract 3.2 on both sides. And I say simple, yet I pull up my calculator. 4.4 minus 3.2 is 1.2. When I subtract 3.2 on both sides, let me show you some steps here. Minus 3.2. If I had written out my steps, it would have been a lot easier. Okay, I'm going to go ahead and do 5 minus 1 is 4d. Then I'm going to divide by 4. And then I get my final answer, d equals, I'm guessing 0.3, because 12 divided by 4 is 3, and 1.2 divided by 4 is 0.3. So they gave me a sub 1 and a sub 5, which means they also told me n equals 5. Because I'm just asking for d in this, I plugged in everything I knew, solved for d. Now I could write the equation that represents this sequence if I wanted to. All right. So that's how you use the formula to find missing pieces of a sequence. But don't forget, we're also talking about arithmetic series. Series is the sum of all the sequences. So I could create a sequence and then add them all together. But the nice thing is, we also have these formulas that help us do that without having to create the entire list of all the values and then add them all together like we did last week. So you'll see we have two formulas here, and it just depends on what information you have. The first formula, S sub n, don't forget that means sum, the sum of the n number of terms, requires n, how many terms you want, and the first term and the last term. So again, if I know the first term and I know the last term, then I know n because n is the number of terms. I can just plug into this formula and it'll give me my sum. The second formula is a little bit more complicated. However, it's more common because usually we don't know the last term. We just say, here's part of a sequence, find the sum of all of these pieces. So we will know n, which we need again in the formula, and we will know the first term, which we need in our formula, but then we'll also need our common difference. So if we know the first term, a sub 1, and the common difference, then we could find the sum of the first n terms. They're always going to give you n because that's how many terms they want you to add together. Let's try one, shall we? Make a little bit more space for myself. There we go. Okay, so find the sum of the first 50 terms in the series 11 plus 14 plus 17 plus dot 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 plus 158. So again, still this sequence and series kind of things. The series means them all added together. If this was a sequence, it would just be 11 comma 14 comma 17, so on. But because they're all being added together, then we know it's a series. So we know a sub 1 is 11 because that's the first term in the sequence. We know that the common difference here is adding 3, so that's d. And then this is what tricks up a lot of people. A lot of people might think this is our last term. We don't know that for sure. Yes, it is the last term in this sequence, but we don't know if that's the 50th term or the 1,000,000,000th term. So therefore, we can't jump to the first equation. We have to use the second one because we have the first term and d. So we know this part and we know d. And because they tell us we want the first 50 terms, that's n. So now we have all three of those parts. We can find the sum of the 50 terms. So we replace n with 50. And then we do 50 over 2 times 2 times a sub 1, which is 11, plus 50 minus 1 times d, which is 3. Whoa, lots of stuff there. Use your calculator. Double check your work. N is 50. 2 is part of the formula there. 2 is part of the formula here. 11 is a sub 1, check. Plus is the formula. 50 is n, check. Minus 1 is part of the formula. And then d we said was plus 3. All right, so I'm just going to pop out my calculator here. Oops, I'm going to stop this for a second. Come back to that. And I'm going to plug it all in at once so you guys can just see how I would do this. 50 divided by 2, close parentheses, 2 times 11, close parentheses, plus 50 minus 1, close parentheses, times 3, close that one, and close on the end. We get 4,225. Excellent. 4,225. Cool. All right. Again, we identified what we were given. The first 50 terms, that's n. They showed us part of the sequence, so we knew a sub 1 was 11, and we knew the difference between those two things was 3. And then we just plugged into the second formula because all I had was a sub 1 and d and n. All right. I think the second formula is just like that. It's exactly like that. So I'm going to do this one a little bit quicker, and then we'll get to example 5, which will require the first one. This one does not. Okay, so looking at this bad boy, we've got a sub 1. That's our first term. I know that the difference here is 9. So that's D. I'm using the second term and third term here simply because the first term is a little bit crowded and I didn't want to moosh all those together. But 173 plus 9 is 162, so it's still the same. And then N is 23, because that's our 23rd partial term. Okay, so S sub 23, the sum of the first 23 terms, is equal to N 23 over 2 times A sub 1, 2 times A sub 1, 2 times A sub 1, 173, plus N minus 1, 23 minus 1 times D. And again, a big ugly thing that we're just going to plug in our calculator. 23 divided by 2, close parentheses, 2 times 173, close parentheses, plus 23 minus 1. Isn't it fun to listen to Mr. Mossman read what's on the screen? Oops, too many parentheses. And enter. 6,256. If I make a mistake, will you please email me and say, Mr. Mossman, you did that totally wrong, and I will go back and fix it. All right, that is a large number for a large series. Okay, last example is going to go back to our sigma notation, and you guys probably recognize sigma notation has this symbol sigma. And remember, this notation here means all of these terms added from the first term to the 42nd term added together. That's what this notation means. And don't forget that that 2n, that's our explicit formula. So they gave us the formula in this case, and they're telling us we want the 42nd term, 42 terms, and then add them all together. So what we could do is we could find all 42 terms and then add them all together, but we don't have to because we've got formulas for that. So the first formula we had said if we knew the first term and the last term, A sub 1 and A sub n, then we could use that formula. The second one is A sub 1 and D. The explicit formula in its simplified form for arithmetic sequences is not always as easy to find D. So therefore, it would be tricky to identify D for this one. However, that sigma notation gave us the explicit form, which means we could find A sub 1 and A sub 42. That's what we're going to do. All right, so back down here, we need n, which is the number on top. So that's n equals 42. And we need A sub 1, which is 2 times 1. The explicit formula, you just plug it in. 2. And then we need A sub 42, the last term, which is 2 times 42, which is 84. So we know n is 42, A sub 1 is 2, A sub 42 is 84. I'm going to go back and double check my formula one more time just to make sure I have it correctly. Part of my work that's following us. N over 2 times A sub 1 plus A sub n. So if I'm right here, and I'm going to write that down just so we can see it next to our work. A sub n is equal to n over 2 times A sub 1 plus A sub n. I know n, I know A sub 1, and I know A sub 42. So A sub 42 is what we're looking for. No, S. Pay attention, I just made a huge mistake. We're not looking for A sub 42 this time. We're looking for S sub 42. That's the sum of the first 42 terms, not what the term 42 is. So 42 terms divided by 2 times a sub 1, which was 2, the first term, plus a sub 42, 84, the last term. It's pretty neat why these formulas work, but I'm not going to get into it. All right, last time to use our calculator for this lesson. 42 divided by 2 times 2 plus 84. 1,806. That is the sum of the first 42 terms for this series that we have here. If you have any questions, please email me or Ms. Fisher. Please come to our office hours if you have any questions. I hope you guys are doing well. And we'll see you next time.